Hello guys, my name is Eureka Emmanuel. I'm from Information System 2018. So today I'm gonna talk about what is graph, and coloring problem and chromatic number of graph. So don't forget to subscribe, like and share. Thank you. What is graph? A graph is a picture designed to express words, particularly the connection between two or more quantities. A simple graph usually shows the relationship between two numbers or measurements in the form of a grid. If this is a rectangular graph using Cartesian coordinate system, the two measurements will be arranged into two different lines at right angle to one another. One of these lines will be going up, the vertical axis. The other one will be going right, the horizontal axis. These lines, or axes, the plural of axis, meet at their ends in the lower left corner of the graph. Both of these axes have tick marks along their lengths. You can think of each axis as a ruler drawn on paper. So each measurement is indicated by the length of the associated tick mark along the particular axis. A graph is a kind of chart or diagram. However, a chart or a diagram may not relate one quantity to other quantities. Flowcharts and tree diagrams are charts or diagrams that are not graphs. The points on the graph often represent the relationship between two or more things. Here, for instance, we can represent the data given below, the type and number of school supplies used by students in a class, on a graph. We begin by counting each supply and representing the data in particular colors in a systematic order in a table. Coloring problem and chromatic number of graph. A graph coloring is an assignment of labels, called colors, to the vertices of a graph such that no two adjacent vertices share the same color. The chromatic number G of a graph GG is the minimum number of colors for which such an assignment is possible. Other types of colorings on graphs also exist, most notably edge colorings that may be subject to various constraints. The study of graph colorings has historically been linked closely to that of planar graphs and the four-color theorem, which is also the most famous graph coloring problem. That problem provided the original motivation for the development of algebraic graph theory and the study of graph invariants such as those discussed on this page. In modern times, many open problems in algebraic graph theory deal with the relation between chromatic polynomials and their graphs. Applications for solved problems have been found in areas such as computer science, information theory, and complexity theory. Many day-to-day problems, like minimizing conflicts and scheduling, are also equivalent to graph colorings. In graph theory, graph coloring is a special case of graph labeling. It is an assignment of labels traditionally called colors to elements of a graph subject to certain constraints. In its simplest form, it is a way of coloring the vertices of a graph such that no two adjacent vertices are of the same color. This is called a vertex coloring. Similarly, an edge coloring assigns a color to each edge so that no two adjacent edges are of the same color, and a face coloring of a planar graph assigns a color to each face or region so that no two faces that share a boundary have the same color. Vertex coloring is usually used to introduce graph coloring problems, since other coloring problems can be transformed into a vertex coloring instance. For example, an edge coloring of a graph is just a vertex coloring of its line graph, and a face coloring of a plane graph is just a vertex coloring of its dual. However, non-vertex coloring problems are often stated and studied as is. This is partly pedagogical, and partly because some problems are best studied in their non-vertex form, as in the case of edge coloring. The convention of using colors originates from coloring the countries of a map, where each face is literally colored. This was generalized to coloring the faces of the graph embedded in the plane. By planar duality it became coloring the vertices, and in this form it generalizes to all graphs. In mathematical and computer representations, it is typical to use the first few positive or non-negative integers as the colors. In general, one can use any finite set as the color set. The nature of the coloring problem depends on the number of colors but not on what they are. Graph coloring enjoys many practical applications as well as theoretical challenges. Beside the classical types of problems, different limitations can also be set on the graph, or on the way a color is assigned, or even on the color itself. It has even reached popularity with the general public in the form of the popular number puzzle Sudoku. Graph coloring is still a very active field of research. Thank you for watching.